Hi everyone, welcome to another video. In this video we will be solving a problem which is a very common interview problem, rotting oranges, and it can be framed as rotting apples as well. So let us try to understand what is the problem statement. So in the problem statement you are given as an input a grid which is of size, let's say n cross m. So it is a matrix, and the matrix would be kind of having three possible values which could be 0, 1 and 2. 0 means that it is an empty space, right? In that particular grid value nothing is present, no apple or orange is not present. Then there is a value called 1. 1 means that there is a fresh orange present, right? Then there is a 2 which means rotten. So rotten means that it is about to rot. So the idea here is that every minute the rotten um, apple or orange can rot the adjacent. So we can move in four particular directions: up, down, left and right. Right, if we are at ij, then we can move in four particular directions, right? So and every minute it can rot the adjacent neighbors. Okay, so this is the problem statement, and we have to calculate that what is the minimum number of minutes all the apples in the grid will be rot. So that is the problem statement. For example, uh, let's see this particular test case. So this is our initial grid 2 1 1 1 1 0 0 1 1, where the rotten apple is placed at 0 0 index, right? And what happens next? In the first iteration, what will happen at time equals to 1 minute, it will rot the adjacent which is at 0 comma 1 and 1 comma 0, right? So these two particular apples would be rotted, right? In the next iteration, what happens? These two will be your values, so it will rot its adjacent or it can also rot. So it depends, whatever is present first it will rot. So definitely this will rot, and the next adjacent value is 0 comma 2, so this will also get rot. So this would be the state at time equals to 2 minutes. And what will be the state after time equals to 2 minutes? Would be time equals to 3 minutes. So here if you see the adjacent, this is 0, this is empty, nothing will happen to this. Then if you see below, right, below this grid, it will rot the below apple, so this will get rot. Okay, and what happens next? Right, in the next iteration, that is time equals to 4 minutes, it will rot the final fresh apple that is present will get rot. So if you see the final version, there is no fresh apple present, which is good for our condition, because there is one more constraint. Let's say if any fresh apple, if it is present in the grid after everything happens, then you have to return -1 as the output. Okay, so that is one of the constraints. So if you see there is no fresh apple present in the final version, hence we can say these are empty position, which is okay, and then you can basically return the answer, which is 4 minutes, right? So this is the question. So if you see like what is coming into your mind, just you can pause the video, think it through. What is happening is you are going level by level, right? You just insert and you have to maintain some time, right? If you think in that direction. So if you are going level by level, the first algorithm that comes into your mind is the breadth first search, right? It is a straightforward breadth first search approach, but you have to make sure that if the let's say the index or the grid value is visited, it is not visited again, right? So one constraint is that. Another constraint you can see is that you have to be very calculative about the values, right? That if it is a rotten apple or orange, then only you are going to push it into your queue, otherwise it doesn't make sense, right? And another thing is you are going iterations. For example, if you see, this is the first iteration, this is the second iteration, this is the third iteration, this is the fourth iteration. So if you calculate the number of iterations, then it will do the job, right? So this is the thing that is coming into my mind. And now I will move on to the solution which I kind of implemented it, and it will help you understand what I just said, right? How you are going to iterate and how you are going to store the values in the queue. So it would make more sense. So let's, without further ado, move ahead to the solution. So the code I have written here is based on C++, and similar code can be implemented in Java as well. So let's see my approach towards this particular problem and how I am solving this, right? So I have, in line number 3 and 4, I have made two arrays which are kind of direction array, dx and dy. So these move in 4 particular directions. So for example, you can imagine this as a grid, right, where in a number line, so here you are having, you know, -1, 0, and here you are having 0, -1, here you are having 1, 0, and here you are having 0, 1. Makes sense? So this is what I have implemented: -1, 0, 0, -1, 1, 0, and 0, 1. So these are our dx and dy directions. If I am at coordinate 0, 0, these are the 4 directions which are adjacent to me, and these particular oranges can be rotten, right? Makes sense? So let's move ahead. So this is our input parameter, nothing special here. Then we have initialized the time value which we will return at the final. Then we are just calculating the number of rows and columns. If the rows are 0, no need to calculate the column, right, because the answer would be 0 because it's an empty grid, right? So then we are just using a queue. So in this particular queue, if you see, I'm just traversing it, right, and I'm storing the oranges which are rotten. The rotten oranges have a value of 2, line number 15. Okay, now what I will do is that the elements which are rotten are in my queue, okay, that is present in the queue. Now I will have to traverse all of them in a single iteration and push the oranges which they can rot, the adjacent one. Adjacent one can be rotten only if they are fresh. So if the value is 1 of the grid, that means the orange is a fresh orange, right? So that is what we are going to do. So the number of elements in the queue will denote at that particular level in our breadth first search how many nodes are present. So these are the rotten nodes, and all the rotten nodes have to be executed in a single iteration, in a single time frame, right? So that is what we are trying to do here, and then we are executing it. We are just pulling out the node which is there, and x and y, first and second, is the pair value. So this is your x coordinate, this is your y coordinate, and then we are iterating in line number 27 in 4 directions. So the new x and new y would be your new coordinates, the adjacent coordinates, and you know, the crux of the problem is that it has to be you know, a valid new coordinate, and it should not be, you know, it should be a fresh apple. So that is what we are checking here, and then we are pushing into the queue. The important part to note here is the line number 31 where you are making it 2. So why we are making it 2? Because that particular orange or apple will get rot, right? So we will mark it as 2, and it will ensure that it is not visited again. So we are saving a space complexity, otherwise you have to make a visited array and mark it. So we are kind of just populating the value smartly, and that is helping us here. Then once this loop is completed, I am doing a time plus plus, so that it increases your time frame, 0th minute, 1st minute, 2nd minute, and so on, right? Makes sense. Then from line number 39 to 45, I am just checking that whether any apple which is fresh, which cannot be reached from the rotten nodes, Is that possible? If that is possible, that means I have to return -1 as per the problem statement. So we are just directly returning it as -1. And if let's say time equals to 0, that means you don't have any rotten node itself, right? If there is no rotten node, you don't have to do anything, so you will return just 0, right? And in 47 I am returning time -1 because this is one iteration extra would happen every time. So in order to adjust that, I'll just return -1. Okay, so this was the problem statement and our solution. So what do you guys think would be the time complexity and space complexity for it? So I think it should be the number of nodes we are traversing, and in a grid there are n cross m nodes, so we are just traversing each and every node once. So the time complexity should be order of n cross m. Similarly, the space complexity, because in the worst case all the nodes would be stored in the queue, so that is why I have taken the complexity as order of n cross m. So this totally makes sense. So you guys can try this question. It is available online, and it is a very popular question asked in the technical interviews, whether it's SD1, SD2, SD3, every level you can expect this BFS problem. So pretty standard question, and lot of learning opportunities in terms of breadth first search and how you are traversing the nodes, and how you are doing smartly the level order traversal. So these fundamental concepts can be covered in this problem. And if you liked this video and the explanation or code, consider subscribing, liking the and sharing this video, and see you soon. Thank you for watching.